So, as you have recently been focusing more on machine learning and data engineering, so was
Yeah.
that a natural step in your journey or it's a conscious shift?
ML and AI have become so popular. So really, people who are in the data space don't have an option but to look at machine learning and
So,
AI.
sir, for young engineers who are aiming
Mm.
to work at big companies like Lenovo and Apple, so what piece of advice you will give to them to help them stand out?
Or you should be able to basically adapt to the corporate culture and be able to deliver a lot faster, right?
As I've
Some of the
joined Thapar Summer School 2025, so which is
mm,
based on machine learning and deep learning. So,
okay.
what are your thoughts on this program, and what would you like to say to the students who are thinking to join this program in future?
Yeah, I think you guys have done a good job in terms of joining this particular course. Uh, I briefly looked at what they're teaching you in the course, and looks like a very comprehensive
So, hello
course.
everyone. Today's podcast is where we dive deep into the mind shaping the future of technology, innovation, and artificial intelligence. I'm your host, Seerat, and today's episode is an absolute treat for anyone interested in cloud computing, distributed system, and rapidly evolving world of AI. So, guess what? Today's guest is someone who is truly stand at the intersection of enterprise technology and machine intelligence, Mr. Karan Alang. He is a principal software engineer, architecture, and currently at Versa Network, where he is leading initiative in machine learning, cloud engineering, and big data analytics. So whether you are a software engineer, data scientist, cloud architect, or just curious about the future of intelligent infrastructure, today's podcast is all about you. So, without any further delay, let's begin our today's podcast. Hello, sir. How are you?
I'm very good, Seerath. How are you? How are you
I'm
doing?
good, sir.
Okay, great.
So,
Thanks for hosting this.
thank you, sir, for coming on this podcast.
Sure, sure.
So as you have worked in major companies like Apple, Intel, and Lenovo, so what are
Mm.
some key moments or turning point in your career that lead you into the world of cloud computing and distributed systems?
Yeah, good question. So, like you said, I've worked with quite a few companies over the last 20, 25 years. I worked with a company called I2 Technologies. I'm not sure if you've heard of it. It was one of the premier uh, uh, companies in 2000, around 2000, in the area of supply chain.
Yes.
And through I2 I'd worked with, I came to US sometime in 2006, and I had the opportunity of working with companies like Lenovo computers and US Steel and some others. And then, of course, I had gone back to India and came back to US in 2012, I think. Started working with Apple, right? Now, all these experiences have been amazing, right? I don't think I can single out one particular instance, but let me just focus on the Apple experience that I had, which was for about 10 years, 10 plus years actually. So I had the good fortune of working in different groups within Apple, primarily focused on big data, and in the later part on cloud computing. Okay, so within Apple, I worked with the GBI team. I worked with the uh, uh, data center team. I worked on projects like Apple Music. So I was part of the Apple Music launch, right? So those 10 years of my career in Apple, I think, gave me the exposure of working in a big company with some very brilliant people. Okay, so that I think was one of the turning points of my career for sure. Yeah.
So, sir, as you have seen the tech world changing a lot over the last 15 or 15 plus years,
Yeah.
so how has your software architecture evolved, especially for building large scale systems?
Yeah. So I think initially it was more so prior to 2010 or so, it was you know standard server. I mean, standard architecture, which could be primarily client server architecture, right? You had technologies like Java, C, C++, those kind of technologies which were at the forefront, and then the cloud came in, right? So sometime around 2010, maybe a little bit earlier too, but after 2010 became really popular, cloud computing. Big data actually became very popular with the entire social media coming into picture, right? You had huge volume of data coming in, and that's where technology like Hadoop, right? And after that, Hadoop became very popular at one point of time. After that, technologies like Spark and Kafka came into the picture, right? So big data became a pervasive space. Everybody was getting into big data, and that is when I actually joined Apple. We started working on Hadoop and Hive and some of the other big data technologies. So big data was the big in thing at that point of time, and then cloud computing came in, right, with Amazon and Azure and and GCP as well, right, and some of the other players. So from big data, the technology focus started becoming cloud, right? People didn't want to spend a huge amount of money in buying all the infrastructure, right? And that's where cloud computing actually came into picture. And now, in the last couple of years, especially with LLMs coming into picture, the entire software landscape has turned to MLAI, right? Machine learning, artificial intelligence. So I think there's been a big shift over the last so many years, and especially the last couple of years with machine learning and AI and LLMs coming into the fore. Things have started moving very fast now. So the pace, while there's been change in the last so many years, the pace of change has increased a lot more in the last couple of years with MLAI. Yeah.
So, sir, can you please share a memorable project or a challenge that you tackled at Apple that really made an impact either technically or from a business point of view?
Yeah, business point of view, the Apple Music project. So I was part of the launch team. That was one of the most successful Apple projects, at least on the software side. Technically, I think the data center project that I worked on at Apple, that was very interesting. So that is where I got introduced to technology like Kafka, Spark, which are still being used, and Kafka is the de facto standard for streaming data, right? So even technology like Prometheus and Grafana are things that I learned at the Apple Data Center project. So that was a very challenging project. The same, many of those technologies I'm using even today at Versa Inc., where I'm working, Versa Networks.
So, sir, so now I'm going to ask a normal question that most of the young engineers want to know. So, when we're building the data pipeline, so there are so many tools out there, like you have mentioned earlier, like Kafka, Spark, and Airflow, and many more. So, how can you decide which one to use in a particular given situation?
Yeah, good question. So there are quite a few technologies which are available in the market, right? So you have to look at what the requirement is, right? So for example, if you want to use something for scheduling, right, you might want to look at Airflow. There can be other solutions or technologies as well. If you're looking at streaming data, right, you might want to look at Kafka. If you want to do heavy lifting of data and processing data, you might want to look at something like Spark or Flink for streaming data again. So it really depends on the entire architecture and what is it that you are looking at. That is one thing, right? In terms of the capabilities of the technologies per se. The other thing that you want to look at is in terms of cost, right? So there are open source technologies that you can probably go in for. There are commercial products. For example, if you might have heard of Confluent. Confluent, they have their own version of Kafka, right, which is based on Apache Kafka, but they have other capabilities built in. So for bigger companies, right, who don't want to take the headache of maintaining their own software or versions of software, or relying on the open source completely because they need more support, right, they might go in for a paid version or a commercial version of software like Confluent Kafka, for example, right? So that is the other piece. Support, cost, right? And of course, the capabilities of the different technologies. So it's a mix of the entire architecture, right? The cost, as well as, of course, the capabilities that you have within your company, right? So for example, if people are very familiar with a technology like Kafka, they'll probably go in for that. If people are more familiar with, let's say, the cloud computing technologies, and they want to go in with a particular cloud computing vendor, for example, GCP. They might go in for with something like cloud PubSub or one of those technologies, right? So it's a mix of quite a few different architectural and financial decisions that decide what you want to use in terms of software. Yeah.
Thank you for sharing such a wonderful information with the young engineers. So, as you have recently been focusing more on machine learning and data engineering, so was that a natural step in your journey, or it's a conscious shift?
Well, it was actually a combination of both, right? Because I've been involved in the data engineering space for quite some time, right from the time I joined Apple, and big data was a natural step because you have a huge amount of data coming in, and now with so much of data, right, being collected by all these companies, ML and AI have become so popular. So really, people who are in the data space don't have an option but to look at machine learning and AI. With LLMs coming in, now everybody is able to actually use. People have started using it a lot more, right? Everybody knows how to use LLMs, right? Everybody is using it, right? So it's become all pervasive. Every company now is having to open source their models in many ways, right? So it's a natural extension of being in the data space. You cannot escape that, right? And the good thing is, at least from my perspective, I really enjoy working with data and MLA. So it's something that was kind of happened, and there's no way to avoid it. But I'm kind of enjoying it a lot.
So, sir, for our young engineers who are aiming to work at big companies like Lenovo and Apple, so what piece of advice you will give to them to help them stand up?
Yeah, good question. So in the last couple of years, right, things have changed quite a lot, as you know, with LLMs. Again, I'm mentioning LLMs quite a few times because everybody's using it, everybody's talking about it, right? And the other thing is, it has made development so easy, right? You have products like Copilot. Everybody started using it. In fact, in my company, Versa Networks, we have started using Copilot as well. And what that has done is it has made software development, the process of software development, a lot faster than what it was earlier, right? So things which would take, let's say, about a month gets done in a couple of days' time, right? And that essentially means that people who are joining the industry now, right? They, for one thing, I think people who are graduating right now, people like you, for example, right? You're a lot more prepared because you're already doing a lot of MLA in your college, in your course as well, I believe, right? So you guys are a lot more prepared now at this point of time. But having said that, I think the challenge is to be able to not just know a few technologies, but be able to do the software thing a lot faster, right? So while you guys have the advantage of having studied all the different technologies in college, right, you will also have the tough. You should be able to basically adapt to the corporate culture and be able to deliver a lot faster, right? Some of the simpler things like which earlier fresh graduate could do, the LLMs are able to do a lot faster. So I think it'll be a balance between the knowledge that you have, right, that the people who are graduating now, right, they have, plus the ability to do things a lot faster and be able to show that you've already done a lot of work before you start joining the corporate world.
So, sir, as I am currently as I've joined Thapar Summer School 2025, so which is based on machine learning and deep learning. So, what are your thoughts on this program, and what would you like to say to the students who are thinking to join this program in future?
Yeah, I think you guys have done a good job in terms of joining this particular course. I briefly looked at what they're teaching you in the course, and it looks like a very comprehensive course. I think my advice would be to essentially make sure that you are really thorough in you take active interest in learning whatever is being taught, for one thing, right? Also see if you're able to do a lot of projects outside of what is being taught, right? Because eventually the companies will look at not just what you've learned, but also see if you have done pet projects, or maybe done things like contributing to open source. In fact, I'm working right now with some of the students from one of the Canadian college, and they are actually working on the Airflow open source project, and I'm one of the maintainers for that. Okay, so a lot of the students are already doing that. If you're not doing that, you should consider working on some of the open source projects. Make sure you have a catalog of projects that you have done, specifically on MLAI, right, deep learning, right, and so all that I think will probably help you. But as far as the course is concerned, I think that's amazing. You have to probably go beyond that and make sure your resume looks really good in terms of the internships that you do, in terms of the projects that you've done, right, and in terms of the open source contributions that you have done. But the course wise, I think it looks amazing.
So with your experience in distributed systems, so what are some common mistakes or misunderstanding you see that the young engineer make when they are trying to build a scalable systems?
Yeah, so there are quite a few. For one thing, the young engineers, one is of course being able to design the entire architecture, because there are different moving parts in a distributed system, right? So you have to look at scalability, you have to look at security, you have to look at the right choice of product, right? Technology, we talked about that a bit earlier, right? You have to look at observability, right? You want to make sure that, because there are so many different distributed systems, essentially means that you have different, you have multiple small, let's say microservices, or multiple small computers which are doing the work together, right? So that is what distributed system actually means. So when that happens, there are a lot of different areas where the system can actually break, right? And you should be able to figure out, when you have an issue, you should be able to figure out where the issue is and be able to fix that quickly, which essentially means that you have to have, you want to know what the status of the system is at all times, right? So you have to be able to use products like Prometheus, Grafana, and make sure you have an understanding of what the system looks like. And if it breaks, you want to make sure that you get alerts, or the right people get the alerts, so that they can go ahead and fix it. So quite a few things. It's a pretty exciting and huge space, right? And but the areas of failures are quite a few. Areas of considerations are quite a few with respect to architecture.
So, sir, apart from this technical knowledge, would you please give advice to youngsters who are going to join the engineering field, that what kind of course or skills they should develop in themselves?
Yeah, so I briefly did mention about this. So, in the courses, the kind of course that you are doing looks fantastic, right? You could, if you are more interested, if you're interested in other courses, there are courses which are from some of the big universities like UC Berkeley and UMich, University of Michigan. They have some really good courses on Coursera. But more than courses, I would say, the hands-on experience and the different projects that you do. Okay, that will help a lot more. I mentioned about open source contributions. That will really help too, right? And there's so many different areas that you can actually contribute to in terms of open source. For example, I'm working with Airflow right now. You have products like Spark or Kafka. You can choose whichever, even cloud computing for that matter. I think there are quite a few different things that you can do. You can learn and you can actually contribute to some of these projects, right? So courses are fine. Courses can get you to a particular level. Beyond that, I think what companies will look at, especially when you go onto the job market, is what is it that you have learned, or what is it that you've done, right? How have you applied the knowledge that you have gathered in the courses that you have done, right? So I think that is the key. So those are some of the things that I think you might want to look at, right, in terms of as a fresh graduate, for example. Yeah. And I think the other thing that you also want to focus on is in terms of the soft skills, right?
Yes.
A lot of people can do a lot of stuff, right? Technical stuff. They can sit for hours together trying to solve a particular problem, which is good, which is very important. But then also other things that in a bigger organization, for example, right, is how do you actually communicate with your uh, with the teammates, with the seniors, right? So in terms of identifying a problem, communicating a problem, or even things like working in a team, right? There are going to be different personalities in a team. Can you actually work together in a team, right? Because not everybody cannot do everything. So being able to support different people in the team, being able to put your hand up for a problem which is probably a tough problem, and there's a possibility of failure. So those kind of things actually will help when you actually join the corporate world.
So thank you, sir, for sharing such a wonderful information with all the youngsters who are going to watch this podcast.
Sure.
So first of all, thank you for giving us time for the podcast. As we know that you are having such a busy schedule, still you are giving us the time for this podcast and sharing such a wonderful message with all the youngsters. So on the behalf of them and on the behalf of Thapar Summer School, I'm really thankful to you, sir. Thank you, sir.
Thank you. It was a pleasure talking to you, Seerat.